Well, I'm Johnny Miller from Central Welding Works. We did the structural steel fabrication, detailing and erection on University of Pretoria. I think it went up to about a 200-ton job, something like that. And steel was used throughout the job in various places. There's a big warehouse with the crane beams and columns, and quite a few feature columns in the entrance foyer with the curved roof on plan. I don't think we rolled any steel in that curved foyer anywhere. So it was very well detailed, and that's pretty much the first brief, if anyone wants to add.
Okay, Marie, you want to introduce yourself and tell us about what your role in the project was?
Hi all, we are ARC architects, so we were the architects on the job, and we did this presentation for the building for the University of Pretoria. It's a collaborative training and referencing testing facility between the University of Pretoria and SANRAL and CSIR. It's the first of its kind, so it was quite interesting to dealing with that. And the project has three main components. It's the SANRAL laboratories, the concrete laboratories for the university, and then a main foyer section that is between the shared facility between the two, and will function as a entrance space for the future phases of this facility. So this is first phase of many phases to come as the different facilities comes onto board with joining the project. We're on an existing site which had a dense forest, so there were some challenges dealing with that. But in the end, it was a quite successful design, I think, collaborative work between all the parties, and the steel function of the internal versus the external of this building.
I think there's one bit of bad news about the project, looking at the present company, is that the actual steel lab is yet to come. So we are dealing with a little bit of an amorph situation, that we have different aspects. It's the civil and structural that was the first phases, and geotech, but the actual structural engineering component is yet to be added. And I think in that we're actually dealing with, as stated, the very boring first phase, and the fun parts will come later. But what's also quite interesting in the project is that it's not only the structure of the project, it is the actual operational component that comes further, dealing with mechanical, dealing with railways, dealing with on-track rail assessments and monitoring, and putting in all sorts of monitoring and testing devices.
Great. Johnny, can you give us a little bit of insight into the actual structural framing, and then maybe some of the challenges that you had during fabrication and erection?
Okay, so this is just the overall 3D view of the job. So it shows the main warehouse and then there's the big warehouse at the back with staircases and this frame and the screen and everything at the back over there. And so the difficulty in this job is that along this whole side and in this foyer, there were steel beams. I know that we took photos and sent it to the judges last week of getting all those steel beams straight and everything to look, and the interface between steel and glass was quite difficult. The beveled columns in front here were also rather difficult to get right. Everything there all lines up, and there's all different levels coming along here. And the challenge of getting all the steel beams between the pre-existing concrete columns, getting them all level, was quite a challenge. But everything else seemed to work out without much hassle. The trusses are fairly straightforward. They're just different lengths, and the different levels were taken into account like that. I'm not sure if there's any other interesting features. I can get some more photos to show you, and we can take it from there. Is there any other questions on that?
You might have seen the radial grid that we've integrated with the rectangular grid, and that was not inspired by another architect's flight of fantasy. I think as a background to this whole area, what is very important is that we had to erect the structure in a very biodiverse scenario and needed to promote biodiversity in this whole project. As Marie intimated, we're building right within a rather dense forest, and at the advent of this project, we actually measured each and every tree in the entire forest, and as the trees just opened up, it led us to a position to have a rectangular grid bisecting one another at the main entrance, and the curved section was just so clear, was due to a clearing in the forest. And as we said, as we're going on to the next phase, that was such a clear direction giver that we're just having a radial structure as well. But what that also led to, apart from the roof, we wanted the whole structure to be very light as for the protection of the trees, and we're right in close proximity of nature. And from that, we wanted to have a almost totally invisible wall, so to speak. And I know I'm talking a little bit against steel in saying that, but what the capabilities that steel gave us, it was so great that we could actually do that and elevate the whole structure and having almost an uninterrupted view onto the trees, promoting all the aspects of biodiversity, promoting biophilia, as well as general wellness of all its inhabitants. So that's a great contributor from the attributes of steel that we were able to incorporate in the building fabric. My apology for interrupting.
No, that's fine. No problem.
Thank you.
Any questions from the judges so far? Johnny, how would you say that this project specifically demonstrates the benefits of steel as a material?
Demonstrates the benefits. Well, I don't think you could achieve the spans required in the warehouse without steel. That wouldn't be possible. It's just a normal concrete roof, so simply. Cost of manufacture, timelines in the program, all those things were there that were required in order to make it better. Like steel was required for all those. Like you couldn't have achieved the look the architects wanted as opposed to the actual structural framing of the building without steel.
Great. Last question from me, and then we'll see if the judges have any further questions. What would you say, maybe, well, this will be a question for the architects to answer first. What are you most proud of in this particular project with regards to the steelwork?
Is directed at ARC. Yes, with the facility being a training laboratory with students coming in, it was essential for us to keep the steel structure as an open architecture element. So one of the items or important aspects were the workmanship of the steelwork, and I think that was successful on this project. It was really essential to achieve the right quality of work to show the students coming into this building what building should look like and steel should look like. We are dealing, as Johnny said, with large expansive spaces where which helps the future changeability and adaptability of the building, with the eastern wall being a steel structure that can be expanded in future. Steel is quite versatile in that sense. You can take it down and move it along as the facility expands. So
as we already did with the project.
Yes, yeah, it already happened once with this first phase. Yeah, so I think the slender design, materiality or elements of steel lended towards, like Anton said, that transparency between the inside and the outside. So we couldn't have done it without the steelwork. So
I think there's also a little bit of a integrated and hidden part of steel because of what we did in the Hemisphere, where we've used tilt-up concrete elements. And obviously, I think that is where steel also comes to its full. We were dealing there with panels of 9 meters by 7 meters, which is just 150 millimeters thick. But obviously, without the rebar and appropriate use of rebar, that would not be possible. So I think in all, steel contributed to rebar. I think if you're looking at elements, operational elements in the actual project, looking at the strong floor that we have, which is 1.2 meters thick of concrete, and the rebar on that, I don't know if you had sight of that, is very closely woven to be able to provide us that strong floor. So, and we've also, as part of the open architecture, in many ways, not only limited to the visual aspect of the steel, but also in terms of the rebar, in terms of the structure, the holding down bolts, everything. We've opened that is again from an environmental and from a educational point of view. All these elements are exposed and just makes it so much easier for students to learn.
The general part of this job was the coordination went very well most of the time in terms of detailing and getting information out that worked. The concrete and steel drawings all lined up most of the time without much hassles, and the architects were on board with all the approvals. And that's kind of what happened on this. So without the streamlined team and the use of Tekla and 3D modeling and getting all that stuff done, it would not have happened nearly as quickly as it would have happened before.
Yes, we did extensive coordination drawings, first of all, between the consultants on the job, and then further with Johnny and crew detailing. So it was a smooth process with that regard, using the technology we've got available these days. That helps a lot.
Sorry, can I have a quick question? Now, we've heard on a couple of occasions, especially in the Steel Awards, about the greater coordination between all the different disciplines and the fabricators and the site work. There seems to be a lot more collaboration. How does a professional see that having changed over the last 2-3 years?
Franco, if I might come in there, we've seen that coming in on leaps and bounds. And let's always start with the negative, because as a good project management manager friend of mine, it's always easier to say what you don't want than it is to say what you do want. And I think the worst thing that you can have on any project, if you have X amount of subcontractors, consultants, waving arms, screaming, and trying to sort out the impossible, which is already in place and just costs everybody money. So I think the financial aspect in the first place is absolutely impertinent and very important to get it right in terms of coordination. If you're looking at the first phase of coordination and now on projects we do, we absolutely insist that all consultants are software and more specifically Revit competent. And if we're looking at taking that further into different advances in Revit, I mean, we're up to 360 glue at this point in time, which effectively also makes it far easier, because if any consultant, or for that matter, I think we will be seeing soon in the future, everybody growing, collaborating directly with the subcontractors, consultants all together, that you are in fact not in a position to add anything to a model if it clashes with something else. So that's really getting proactive in that field. So let's say that's where we're at now. One step back, you do have a situation by everybody collaborating. You do have a clash detection spreadsheet that is sorted out. And I think in total, the major brunt of all coordination, all services coordination on this project, including structure, took us, I think, a period of 4 weeks, where we started off with having clear guidelines. I think we had something like 1,100 clashes. And within 3 weeks, we had it down to about, I think, 17 and we worked with 17 for a moment, well, for a week or so, and thereafter a lot was sorted out. I think if you want to ask me where we need to go in the future, and I think this is just the way the South African system works, is that subcontractors, and I think the steel subcontractors is far advanced in that field to collaborate with others. But if you're looking at in all probability electrical, they are lagging a little bit behind, because I don't think it's their current focus, but that's something that can very quickly change. So we just see that time and cost saving in doing your coordination with the use of software upfront is just a tremendous help.
Okay.
And sorry, the last point I just briefly want to make is also in terms of virtual reality, because we are using virtual reality not just as a marketing tool, but we're also using it as a design tool. It's absolutely amazing if you're taking, for instance, clients M&E project manager, if they are there, because I think something that's always a challenge. We are trying to sell a dream, And a lot of people think they know what this building is going to look like, but even the architects don't know what it's going to look like. So it's actually quite cool. At the end of the day, if you have your client, everybody with a 3D model, looking at, understanding what it is, even your subcontractor, he knows there's whatever pipe or structural element coming in. And it just gives everybody a clearer picture. On site, somebody has to fit it. He doesn't have to have an understanding of the technology, but he's got a visual aspect of it and he knows what to do. It just saves all round.
So quickly, yeah.
Franco, can I add into that? With regards to that, so there is all the 3D modeling and stuff. I'm sure you've seen in Tekla, without using that Tekla structures, there's no way we could manufacture that in time. Because the whole model is drawn in 3D, every part is individually numbered. And therefore each part, each plate, everything is already cut. It's CNC cut, it's all cut exactly to size. You'll get the bevels correct on every plate and every column because it's all done in a CNC environment. So you'll have a 3D model of something like this that is there. So you'll see all these. So if you have a 3D model of these of these beams, you'll know what it looks like and you'll be able to explain to the erectors on site how to pick it up, which beam goes where, and how everything would work out. So you'll see a lot more of this type of thing. Wouldn't be possible detailing in 2D as easily, especially when you go and everywhere around it is different levels and you can't see exactly on the radial grid and stuff like that. It made life a lot easier having all the 3D models and everything there in order to actually produce the job and erect the job.